everyone, I'm welcoming you all once again to this channel. So in the last video we have made some kind of slab, and there we have saved one POSCAR file. So that POSCAR file was like this. So as you can see here, we have made the file for it, like we have created this slab, and it has different so many types of atoms. And you can see that many of such FEC and N atoms, they are actually repeated. You can see this 0 0, this particular coordinate is repeated for 8 times. So this way like we have some repeated coordinates. And now how to delete all these duplicate atomic coordinate, for that I am going to use one code here. So before going for the code, let me also open the same POSCAR in our VESTA software. So here you can see this is the slab that we have created in our last video. And now I am going to open this code here, where we will remove the particular so this is the typical code, where you can see that we have imported the ASE from here, and then from the ASE there is an option like geometry. We have imported the ASE geometry to get the distances. Okay, and from ASE geometry we have imported the distance. Then we are using this particular code where we have set the tolerance as 10 to the power minus 3 angstrom. So this way this way we can write this very simple code, and this is a very predefined code that I have taken from internet, and you can simply run this code. And as we are having our POSCAR file in this particular directory, so I am going to simply run this. Yeah, so it written like removed 420 duplicate atoms. So now the POSCAR clean, this is our new file that we have written after the cleaning operation, that is POSCAR clean. I am going to open that POSCAR clean. So you can see that in our earlier POSCAR we are having 64 Fe atoms, but right now we are having only 4 and 12 carbon and 12 nitrogen atoms. And now I am going to again do the same thing over here. So here I am going to open the POSCAR cleaned in our VESTA software. You can see that both the structure that I have opened earlier and now are same. And as we have seen that only 4 Fe atoms, so we can see which group it is representing. So I am clicking on this atom. So this is representing Fe1. All these corner atoms are Fe1, so all are Fe1. And then this central atom is Fe2. So you can see this is Fe2. And this atom, these four atoms are Fe3 group, and this top and bottom atom is in the Fe4 group. So this way Fe4 and their corresponding CN6 and C6 their corresponding, yes, FeC6 and FeN6 atoms are also present. So this way we can write a very simple code to remove our duplicate atoms. And this much for today's session, and I hope all of you have you are following these tips. Thank you all, and bye bye.